Good morning, my name is Christopher and I'm from Loughborough University. Today I want to present retrofit of dwellings in Chinese cities. And this research formed part of the low HQ project, which is low carbon climate responsive heating and cooling of cities operated by University of Cambridge and some collaboration with Chinese universities. So as you know, China is a large country and there's many climate zones in there. From the very bottom, hot summer and warm winter regions, such as Hong Kong, where I come from, and the very cold region, which indicate as the dark blue area, such as Harbin. And in this research project, I'm going to investigate the central region, which is the hot summer and cold winter region. And two cities will be investigated. The first one is Chongqing, which is in the middle of China. And the second is Hangzhou, which is just a little bit south of Shanghai. And as you know, in this region, they have very hot summer, around 30 degrees Celsius, but really cold winter, down to 5 degrees Celsius. And there is a regulations proposed by the government that there is no central heating installed in this region, and therefore people need to rely on air conditioners for heating and cooling, and also some people may use fan heaters and electric blankets for heating. And therefore, you may think about like what's the indoor temperature inside the building. And you can see from the fifth picture that the x-axis is the outdoor temperature and the y-axis is the indoor temperature. In summer, for both North and South China, it is pretty good for the comfort. The temperature is around 20 to 25 degrees. But in winter, you can see a huge difference. In North China, they have heating, so the indoor temperature keep around 20 to 25. But in South China, the average is 10 to 15. Some of the houses can even bring to 5 degrees Celsius, which is really cold and uncomfortable. And as living standards is increasing in this region of China, people will want to have heating, central heating installed in their houses. However, if central heating is installed just like northern China, there will be a tremendous increase in energy use. And therefore, some kind of solutions may need to be proposed in order to both improve the thermal comfort in these cities, but also limit the energy cost. So the research will focus on Chongqing in this instance, and it is a region in China which proposed of 30 million residents and is about 1/3 of the size of the UK. And here is the city area, which composed of 7 million of residents. And this picture is taken in the core area of the city. As you see, there's tons of buildings there ready for retrofit for the dwellings. There's around 200 buildings in such a small area. So you can see the scale of the research is vast. So my research question is to investigate the retrofit options for dwellings in cities located in this climate zone, and by choosing the appropriate active and passive system in order to improve thermal comfort and minimize heating and cooling energy use. So because I've started this project for approximately 5 months, so the results are still pretty preliminary, and I'm not entirely confident about the accuracy of it. But up to date, what I've done so far is a monthly quasi-steady state calculation implemented by BSENO ISO 13790. And I need to put some boundary conditions, which are weather data, for example, external temperature and solar radiation, and then occupancy and some casual gains. And for parameters, which are geometry of buildings, construction characteristics, and heating and ventilation specification are also important. And these two kind of stuff are found from local codes and regulations, or some information provided by the research team of the Low HQ project. And what we get obviously is the output variables, which is the heating and cooling energy demand per unit floor area, which we are interested in. However, in this quasi-steady state calculation method, we cannot know about the thermal comfort inside the houses. So here are the primary results I have derived from the quasi-steady state model, and it basically describes flat which is modeled in Chongqing and provided by the research team. And I put this flat in London to compare the heating and cooling energy difference. As you can see, because London is much colder than Chongqing, and it used much larger heating energy, which is the red line, and much lower cooling energy, which is the blue line. And it used slightly more energy than that in Chongqing, which is indicated in the green line. And for the monthly energy consumption shown in figure 2, as you can see, like in April and September, which the dotted line is London and the solid line is Chongqing. In London, people still use heating in April and October, indicate the heating period in London is much longer than in Chongqing, because in Chongqing they have shorter heating seasons than London. And so, as you can imagine, there's tons of input parameters which can affect the energy use in the dwellings in China. So basically for me, I derived it to 3 tiers. The first tier is that parameters are quite easy to change. For example, the U value of window. Basically, you can change the windows to different U values and can have different energy users. And the second tier is parameters that need to adjust the occupant behavior, such as how long people will open their heating and cooling, because it's quite hard to control the residents open less heating and cooling in order to reduce the energy consumption. The third tier, which is quite hard to change, for example, the U value of wall. So it's quite expensive and long-term process to change the U value of the wall in the retrofit process. And so for the table 2, I derived 3 occupancy regimes, which represent different family compositions in China, namely 2, 3, and 4 occupants, and with different internal heat gains. And basically, when there's lower number of occupants, there will be smaller internal heat gains. People will use more heating, or people use less cooling, and they will increase the heating and cooling set points appropriately. And according to the tiers I mentioned before, I do a very simple optimization for the tier 1 input parameters, which basically change from the base case, which is used in local codes and regulations, to a more tightened value, which seems more feasible. And you can see in figure 3 that when the parameter is optimized, the heat energy is reduced quite a lot, but the cooling energy doesn't reduce a lot, that of the heating. And as you see from the occupancy regimes simulation, the regime 3, which has more people in the flat, they use more cooling energy than the regime 2, and they use less heating energy accordingly. So this is the very preliminary stage of my research, which the highlight one is to use monthly quasi-steady state calculation to estimate energy use in a flat. And then I would like to use Energy Plus to design base case models in 3 selected flats in Chongqing and Hangzhou, and also with 4 occupancy regimes with different family composition in China. Then I would like to use monitor data over 2 seasonal cycles to validate base case models, and these data will be measured from the research team. And use sensitivity study to find out important input parameters in order to know which parameters are more important and prioritize them in the optimization, which I'm going to do to find out retrofit options to achieve minimum energy use. And finally, using the retrofit options, develop a standard study to tower blocks and city scale. So at last, about the benefits of this research, actually it provides pretty representative predictions because I include 4 occupancy regimes and 3 different flats, so there's a 12 base case involved, and provide an optimum solution as both sensitivity analysis and optimization is done to retrofit buildings in China. And at last provide micro and macro risk of the problem. For macro risk, because I will include the tower blocks and city scale in the study. For the challenges, as there are 12 base case models, the sensitivity analysis may lead to quite a long simulation time, and then the selection of the design solution after the optimization is actually quite difficult to perform because I need to choose the optimized solution by experience and stuff. And at last, the scale of the tower blocks and city study is huge. As you see from the photo I shown in the previous slides, there's many buildings in there, and therefore quite a lot of data need to be collected and analyzed. And I have also included a poster presentation outside, so if you want to know more about the details of the work, you can ask and see the poster outside the area. So this is the end of my presentation. Thank you.
Thank you very much.